Okay, so now we want to fill in our table just like we did before. So when x equals -2, I'm going to plug into my equation y equals 5 times absolute value of a -2. A -2, the absolute value of a -2 is 2, so we're going to have 5 times 2. I'm now putting it in parentheses because these are being multiplied. It's no longer in absolute values, right? These are parentheses. Just means multiply. So we get y equals 5 times 2, which is 10. When x equals a -1, we have y equals 5 times the absolute value of -1. Well, we know absolute value of a -1 makes a +1, and 5 times 1 gives us 5. When x is 0, we get y equals 5 times the absolute value of 0. Well, the absolute value of 0 is just 0, and any number multiplied by 0 is 0. Oops, and I forgot to put my 5 here. Okay. When x equals 1, we have y equals 5 times the absolute value of 1. The absolute value of 1 is just 1, and 5 times 1 is 5. And last but not least, we have x equals 2. We get y equals 5 times, jumping ahead of myself. We get 5 times the absolute value of 2. And the absolute value of a +2 is just a +2, so we get y equals 10 again. The difference in the example we did earlier, where we had y equals absolute value of x plus 6, the difference was the 6 was on the outside of our absolute values. It wasn't inside, right? 5, or the -5, is actually inside of my absolute value signs, which means these two things are two different transformations, okay? The +6 that was outside of our absolute value signs, that took us up 6, okay? So this -5 that's inside, the numbers inside of your absolute value sign, that's what's gonna take you either left or right, okay? So let's look at it. All right, we're back to Desmos.com. And now we're going to do y equals the absolute value of x minus 5. If you guessed it, it would shift our graph left or right. You were correct. If you thought it would shift our graph left, you were close, but no. So even though normally you would think minus, right? If it was a minus, it would go towards the negatives, right? When it's inside of the absolute value bars, it does the opposite of what you would think. So -5 inside shifts our graph right, actually, okay? If I were to have put, say we did +5. +5, adding 5 inside of the absolute value bars, that's gonna shift our graph left, okay? So the graph itself is exactly the same. Nothing has changed except it's been shifted 5 to the left from our origin, okay? Or in our case for the problem we're doing, it's been shifted 5 to the right from the origin. So we would say that the black graph, our new graph, has been shifted right 5, or it is to the right of the red one, our parent function. All right, and let's look at our table here. So if we have, we'll look at when x equals -2. It doesn't always have to be these numbers. These are just kind of easy to see because you can look at negative numbers and positive numbers. So say when x equals -2, we're plugging in -2 for this x value. So we have -2 minus 5. Both of these numbers are inside of my absolute value signs. So I can go ahead and combine those because they're together inside of my absolute values. So I want to combine those first and then take the absolute value of that number. So a -2 minus 5 more would put us at the absolute value of a -7. And we know the absolute value of a negative makes a positive. So we get y equals positive 7. Let's look at when x is a negative 1. So we have y equals the absolute value of negative 1 minus 5. Okay. Negative 1 minus 5 gives us the absolute value of a negative 6. And the absolute value of a negative 6 gives us a positive 6. Let's zoom in some. Okay. When x equals 0, then we have y equals the absolute value of 0 minus 5. 0 minus 5 is just negative 5. And the absolute value of a negative 5 makes a positive 5. Right? And lastly, x equals 1, then we have y equals the absolute value of 1 minus 5. And 1 minus 5 gives us a negative 4. So we get y equals a positive 4. Okay. And then last but not least, when x equals a positive 2, we have y equals the absolute value of 2 minus 5. And 2 minus 5 gives us a negative 3. So we have the absolute value of negative 3. Which means y equals a positive 3. All right, last example. So for this one, we have f of x equals a negative times our absolute value of x minus 2, okay? The negative's on the outside of the absolute values. It's being multiplied. So let's look at what that looks like on the graph. All right, so we're back in Desmos. So we have y equals negative times our absolute value of x. You can already kind of see what's happening. And then this one was also subtracted by 2. So let's look at what happened. Our v looks like it flipped down, right? We call that a reflection across the x-axis. So here's our x-axis. Our graph has been reflected downwards. I can't do it on camera very well, sorry guys. But the graph's been flipped over that x-axis, or it's been reflected across the x-axis. And then it's also not just been flipped, it's also been taken down to. If I took off minus 2, you could see it's just been reflected down. All that negative does out front is just reflected across the x-axis, right? And then when I add in that minus 2, it was then shifted down 2 from there. Do you see it? So we're combining two transformations. We've reflected it, which is what that negative does. So we've reflected it across the x-axis, and then we've also shifted it down 2. So the last thing we need to do is just fill in our table here. So let's look when x equals a negative 2. Then I have y equals a negative times inside of absolute value, where my x was, I'm putting negative 2 minus 2. So the absolute value of a negative 2 gives us a positive 2, but we still have to bring down this negative here. So I have a negative times a positive 2 now, minus 2. Negative times a positive 2 gives us a negative 2 minus 2, and negative 2 minus 2 is a negative 4. Okay, let's look at when x equals negative 1. So we have the absolute value of a negative. We have negative times the absolute value of a negative 1 minus 2. So absolute value of a negative 1 gives us a positive 1, but we still bring down this negative that's outside of our absolute values. So now we have a negative 1 minus 2, which gives us a negative 3. When x equals 0, we have y equals a negative times the absolute value of 0 minus 2. Well, the absolute value of 0 is just 0. And a negative times 0 is just 0, so negative or positive doesn't go with 0. So we just have a -2 or a -2. And last ones, when x equals 1, we have y equals a negative times absolute value of 1 minus 2. So we get negative times 1 minus 2, which gives us negative 1 minus 2. So we get y equals -3. And I'm running out of room. Put x equals 2. Then we get y equals negative times the absolute value of 2 minus 2. You know the absolute value of a positive 2 is just a positive 2. So we get -2 minus 2, which gives us y equals a -4.